Hello friends, welcome to Premier UPSC IAS. So continuing with the third part of the geography lessons. This is on geography for prelims UPSC IAS. Okay, let's dive directly into it. Atmosphere. What is atmosphere? The atmosphere is the envelope of gases that surrounds the earth. It is used by life as a reservoir of chemical compounds used in living systems. An atmosphere has no outer boundary. It just fades into space. Dense part of the atmosphere, 97% of the mass, lies within 30 kilometers of the earth, so about the same thickness as the continental crust. Chemical composition of the atmosphere: nitrogen 78%, oxygen 21%, carbon dioxide 0.03%, argon 0.93%, and all others 0.04%. Atmospheric structure. Most of the Earth's gases can be found in the bottom 32 km. This is because, due to the force of gravity, the thickness of these layers is slightly different around the globe and also varies with respect to temperature and season. The atmosphere can be divided into five layers, such as troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Troposphere. It is a region of mixing. This layer is the nearest layer to the Earth and contains the most important share, around 80% of the mass of the whole atmosphere. Temperature and vapor content within the layer decreases quickly with altitude. All weather phenomena occur within the troposphere. The upper boundary of the layer, known as the tropopause, range 8 km from the pole and 15 km from the equator. Stratosphere. The layer is the second major strata of air within the atmosphere. The air temperature in the stratosphere remains relatively constant up to an altitude of 15 miles 25 kilometer, and then it increases gradually go up to the stratopause up to 50 kilometers. Stratosphere occupies the region of an atmosphere from about 12 to 50 kilometer, although its lower boundary tends to be higher nearer the equator and lower nearer the poles. Water vapor content among the layer is extremely low. Ozone plays the most important role in the regulation of thermal regime of the layer. It absorbs the bulk of solar ultraviolet radiation. Stratosphere is sort of utterly freed from the clouds or alternative styles of weather. Mesosphere, the layer extending from about 30 to 40 miles 50 to 85 km on top of the surface of the Earth. It is characterized by decreasing temperature. It records the coldest temperature among the atmospheric layers. Temperatures in the mesosphere drop with increasing altitude to about minus 100 degrees Celsius. It is separated from the layer by the stratopause and from the layer by the mesopause. Thermosphere, an outer layer of the atmosphere separated from the mesosphere by the mesopause. Its temperature rises continuously to well beyond 1000 degrees Celsius. The temperature in this layer is extremely hot and it increases with the height. Thermosphere greatly helps in protecting the Earth and making space exploration and modern forms of communication possible. It also supports and protects life on the planet. It recycles water, absorbs the sun's energy, and helps to create a moderate temperature on Earth. The lower part of the thermosphere, from 80 to 550 km above the Earth's surface, contains the ionosphere. Ionosphere. It is a layer of ionized air in the atmosphere extending from almost 80 km above the Earth's surface, altitudes of 600 km and more. It is not another atmospheric layer. Application: satellite communication possible because of the presence of free floating electrons. Aurorae occur in this region. Aurora: shifting patterns of light which may be seen in the sky. It caused by high energy particles streaming out from the sun. The solar wind striking the Earth's atmosphere or ionosphere. It occurs in both the northern and southern hemisphere. In northern hemisphere, it is called as aurora borealis or northern lights, and in southern hemisphere, it is called as aurora australis or southern lights. It is usually greenish, but sometimes it is red as well. Exosphere. The exosphere is the most distant atmospheric region from the Earth's surface. The altitude of its lower boundary, known as the thermopause or exobase, ranges from about 150 to 300 miles to 50 to 500 kilometers, depending on solar activity. The layer may be a transformation zone between the Earth's atmosphere and space. The atmosphere here combines into space in the extremely thin air. Air atoms and molecules are always escaping to space from the exosphere. Hydrogen and helium are the prime components. In this area, many satellites orbit the Earth. Von Allen radiation belts. James Alfred Von Allen radiation belt could be a zone of energetic charged particles. Solar winds are captured by and held around a planet by the planet's magnetic field. Earth's two main belts extend from an altitude of about 640 to 58,000 km above the surface, in which region radiation levels vary. The belts are located in the inner region of the Earth's magnetosphere, and it traps the energetic electrons and protons. Water in atmosphere. Forms and processes. Water is present in the atmosphere in three forms, namely gaseous, liquid, and solid. The moisture in the atmosphere is derived from water bodies through evaporation and from plants through transpiration. Thus, there is a continuous exchange of water between the atmosphere, the oceans, and the continents through the process of the following: evaporation, transpiration, condensation, and precipitation. The amount of water's vapor in the atmosphere is added or withdrawn due to evaporation and condensation, respectively. The air containing moisture to its full capacity at a given temperature is said to be saturated. The temperature at which saturation occurs in a given sample of air is known as the dew point. Evaporation. Evaporation is a process by which water is transformed from liquid to gaseous state. Heat is the main cause of evaporation. Increase in temperature increases water absorption and retention capacity of the given parcel of air. Similarly, if the moisture content is low, air has a potentiality of absorbing and retaining moisture. Movement of air replaces the saturated layer with the unsaturated layer. Hence, the greater the movement of air, greater is the evaporation. Condensation. The transformation of water vapor into water is called as condensation. Condensation is caused by the loss of heat. When moist air is cooled, it may reach a level when its capacity to hold water vapor ceases. Then the excess water vapor condenses into liquid form. Condensation also takes place when the moist air comes in contact with some colder object. Some other condition when condensation takes place, such as when the temperature of the air is reduced to dew point with its volume remaining constant, when both the volume and temperature are reduced, when moisture is added to the air through evaporation. However, the most favorable condition for condensation is decrease in air temperature. Condensation takes place when the dew point is lower than the freezing point as well as higher than the freezing point. If it directly condenses into solid form, it is known as sublimation. In free air, condensation results from cooling around very small particles termed as hygroscopic condensation nuclei. Particles of dust, smoke, and salt from the ocean are particularly good nuclei because they absorb water. Condensation is influenced by the following factors: volume of air, temperature, pressure, humidity. After condensation, the water vapor or the moisture in the atmosphere takes one of the following forms: dew, frost, fog, and clouds. Dew. When the moisture is deposited in the form of water droplets on cooler surfaces of solid objects rather than nuclei in the air above the surface, such as stones, grass blades, and plant leaves, it is known as dew. The ideal conditions for its formation are the following: clear sky, clear, calm air, high relative humidity, cold and long nights. For the formation of dew, it is necessary that dew point is above the freezing point. Frost forms on cold surfaces when condensation takes place below the freezing point. 0 degrees centigrade. That is, the dew point is at or below the freezing point. The ideal conditions for the formation of white frost are the same as those for the formation of dew, except that air temperature must be at or below the freezing points. Fog and mist. When the temperature of an air mass containing a large quantity of water vapor falls, all of a sudden condensation takes place within itself on fine dust particles. So, the fog is a cloud with its base at or very near to the ground. Mists are frequent over mountains. As the rising warm air up the slopes meets the cold surface. Because of the fog and mist, the visibility becomes poor to zero. The only difference between the mist and the fog is that mist contains more moisture than the fog. Fogs are drier than mist, and they are prevalent where warm currents of air come in contact with cold currents. Fogs are mini clouds in which condensation takes place around nuclei provided by the dust, smoke, and the salt particles. Smog. In urban and industrial centers, smoke provides plenty of nuclei which help the formation of fog and mist. Such a condition when fog is mixed with smoke is described as smog. Precipitation. The process of continuous condensation in free air helps the condensed particles to grow in size. When the resistance of the air falls to hold them against the force of gravity, they fall on the Earth's surface. So, after the condensation of water vapor, the release of moisture is known as the precipitation. This may take place in liquid or solid form. Forms of precipitation: rainfall, drizzle, snowfall, sleet, and hail. Drizzle. This form of precipitation is very small and of uniform size and seem to float in the air. It occurs due to very low stratus type of clouds with higher water content. Snowfall. Precipitation takes place in the form of fine flakes of snow and is called snowfall. It is generally seen in the winter season when the temperatures are below freezing point in a particular region. The ice crystals falling from the altostratus clouds not melt and reach the ground as snow. Sleet. This type of precipitation is in the form of a mixture of rain and snow. Sometimes sleet may grow into hailstorms when violent vertical currents are produced in the atmosphere. Hail. This type of precipitation happens in the form of small pellets of ice, hailstones, with a diameter between 55 to 50 mm. It is the most destructive form of precipitation produced due to violent thunderstorms or cumulonimbus clouds. It is generally seen in the regions between 30 to 60 degree north and south latitudes, which witness the maximum number of these storms. Rainfall. The precipitation in the form of water is called rainfall, where the temperature is lower than the 0 degree centigrade. On the basis of origin, rainfall is classified into three main types: convectional, orographic or relief, cyclonic or frontal. Convectional rainfall. The air or being heated becomes lightweight and rises up in the convection currents. As it rises, it expands and loses heat, and consequently, condensation takes place and cumulus clouds are formed. This process releases latent heat of condensation, which further heats the air and forces the air to go further upwards. This type of precipitation is heavy but of short duration, highly localized, and is associated with a minimum amount of cloudiness. It happens mainly during summer and is common over equatorial doldrums. In the Congo Basin, the Amazon Basin, and the islands of Southeast Asia. Orographic relief rainfall. This type of rainfall occurs when the saturated air mass comes across a mountain. It is forced to ascend, and as it rises, it expands. Because of the fall in pressure, the temperature falls and the moisture is condensed. The main characteristics of this sort of rain is that the windward slopes receive greater rainfall. After rain over the windward side, when these winds reach the other side of a slope, they descend and their temperature rises. Then their capacity to take in moisture increases, and hence these leeward slopes receive no rain and remain dry. The area situated on the leeward rise side hence gets less rainfall and is known as rain shadow area. It is known as the relief rain. Some are arid and some are semi-arid regions are a direct consequences of the rain shadow effect. For example, Patagonian desert of Argentina, eastern slopes of Western Ghats, etc. Cyclonic or frontal rainfall. This type of precipitation occurs when two air masses with different temperatures meet. Turbulent conditions are produced and a long different convection occurs and causes precipitation. For example, Northwest Europe, cold continental air and warm oceanic air converge to produce the heavy rainfall in the adjacent areas. Air masses. When the air remains over a homogeneous area for a sufficiently long time, it acquires the characteristics of the area. The air that with distinctive characteristics in terms of temperature and humidity is called an air mass. It is defined as a large body of air having little horizontal variation in temperature and moisture. The homogeneous surfaces over which air masses form are called the source regions. The air masses are classified according to the source regions. Accordingly, the following types of air masses are recognized: maritime tropical, continental tropical, maritime polar, continental polar, continental arctic. Tropical air masses are warm and polar air masses are cold. Front. When two different air masses meet, the boundary zone between them is called a front. The process of formation of the fronts is known as frontogenesis. There are four types of fronts, such as cold, warm, stationary, occluded. Cold front. Cold front is the one in which cold air is replacing warm air at the surface. They usually bring clearing skies, cooler weather, and a sharp change in the direction of the wind. Warm front. Warm front in which warm air replaces cooler air at the surface. For example, in Oklahoma, warm fronts are rare in the winter and non-existent in the summer. Stationary front. The stationary front is the one that does not move or barely moves. Typically, this type of front is formed when polar air masses are modified significantly so as to lose their character. Occluded front. This is because cold fronts move faster than warm fronts. They can catch up to and overtake their related warm fronts. When they do, an occluded front is formed. They bring abrupt changes in temperature and cause the air to rise to form clouds and cause precipitation. Clouds. Cloud is a mass of minute water droplets or tiny crystals of ice formed by the condensation of the water vapor in the free air at the considerable elevations. According to their height, clouds are grouped under four types, such as high clouds 2000, 20,000 to 40,000 feet, medium clouds 7,000 to 20,000 feet, and low clouds above 7,000 feet. Clouds formation. First, air rises, then cooled down by expansion. Third, dew point reached cooling. Fourth, condensation of water vapor in the atmosphere. Fifth, tiny droplets of water vapor fall as rain or snow will be suspended in the air and flow as clouds. High clouds. High clouds are mainly cirrus or feathery clouds that form at the height of 20,000 to 40,000 feet above the ground. They are following: cirrus, fibrous and appears like wisps in the blue sky. Cirrocumulus, it appears like white globular masses forming ripples. Cirrostratus, it appears like a white sheet or wheel. Medium clouds. Medium clouds mainly alto or middle height clouds that form at the height of 7,000 to 20,000 feet above the ground. They are following alto cumulus, woolly, bumpy clouds. They indicate fine weather. Alto stratus, denser, grayish clouds with a watery look. Low clouds. Low clouds mainly stratus or sheet clouds that are 7,000 feet above the ground level. They are following stratocumulus, Rough, bumpy cloud with the waves. Stratus, very low cloud, uniformly grey and thick. It brings dull weather with a light drizzle. Nimbostratus, dark, dull cloud. It is known as rain cloud. Cumulus or heap clouds. These are the clouds with the great vertical extent or with no definite height. Cumulus, it is white globular masses which may look grey against the sun, but it is a fair weathered cloud. Cumulonimbus, black and white globular masses. It is cauliflower in shape. It is also referred to as thunder cloud. Pressure system and winds. Atmospheric pressure. It is defined as the weight of a column of air contained in a unit area from the mean sea level to the top of the atmosphere is called the atmospheric pressure. The atmospheric pressure is expressed in units of MB and pascals. Due to the gravitational pull, the air at the surface is denser and hence has higher pressure. The pressure decreases with increase in height. At an elevation, it varies from place to place, and its variation is the primary cause of air motion, that is, wind. Vertical variation of pressure. In the lower atmosphere, the pressure decreases rapidly with height. It does not always decrease at a similar rate. The vertical pressure gradient force is much larger than that of the horizontal pressure gradient, but it is generally balanced by a nearly equal but opposite gravitational force. Hence, we do not experience strong upward winds. Horizontal distribution of pressure. Small differences in pressure significantly impact the wind direction and velocity. Horizontal distribution of pressure is studied by drawing isobars at constant levels. Isobars are lines connecting places having equal pressure. The low pressure system is enclosed by one or more isobars with the lowest pressure in the center. The high pressure system is also enclosed by one or more isobars with the highest pressure in the center. Pressure belt around the earth. There are the following seven pressure belts that are not permanent in nature: equatorial low, subtropical high, subpolar lows, and polar high. Equatorial low pressure belts doldrums. The sun shines almost vertically on the equator throughout the year. This belt extends from equator to 10 degree north and 10 degrees south latitudes. Due to excessive heating, the horizontal movement of air is absent here and only conventional currents are present in this region. Therefore, this belt is called as doldrums, the zone of stagnation, due to the virtual absence of surface winds in this region. Intertropical Convergence Zone (ITZ-CZ). These 10-degree north and 10-degree south latitudes are the regions of convergence because the winds flowing from the subtropical high pressure belts toward the equatorial converge here. This belt is also known as Intertropical Convergence Zone (ITCZ). The air at the Intertropical Convergence Zone rises because of convection caused by high insolation and a low pressure is created. Hence, the winds from the tropics converge at this low pressure zone. Subtropical high pressure belts, hot latitudes. These belts extend from the tropics to about 35-degree latitudes in both hemispheres, north subtropical high pressure belt and south subtropical high pressure belt. The existence of these pressure belts is mainly due to the fact that the uprising air of the equatorial region is deflected towards poles due to the Earth's rotation. After becoming cold and heavy, it descends in this region and gets piled up. This results in high pressure. Calm conditions with feeble and variable winds are found here. In olden days, vessels with cargo of horses passing through these belts found it difficult to sail under these calm conditions. They used to throw the horses in the sea in order to make the vessels lighter. Henceforth, these belts or latitudes are so called horse latitudes. These are the regions of divergence because winds from these areas blow towards equatorial and subpolar low pressure belts. Subpolar low pressure belts, polar fronts. These belts extend between 45° north and the Arctic Circle in the northern hemisphere and between 45° south and the Antarctic Circle in the southern hemisphere. They are called as North Subpolar Low and South Subpolar Low pressure belts respectively. Winds coming from the subtropical and the polar high belts converge here to produce the cyclonic storms or low pressure conditions. This zone of convergence is known as polar fronts. Polar high pressure belts. In polar regions, the sun never shines vertically. Sun rays are always slanting, here resulting in low temperatures. Because of the low temperatures, air compresses and its density increases. Hence, high pressure is found here. In the northern hemisphere, the belt is called the North Polar High Pressure Belt, while it is known as the South Polar High Pressure Belt in the southern hemisphere. Winds from these belts blow towards subpolar low pressure belts. Planetary winds. The general distribution of winds throughout the lower atmosphere is known as planetary winds. These are of three types, such as trade winds, westerlies, polar easterlies. Trade winds blow across the latitudes in a belt lying between 5° north, 30° north, and 5° south to 30° south. There is low pressure over the equator while high pressure at the subtropics. So air moves from tropics towards the equator. Due to Coriolis force and rotation of Earth, winds move toward left-hand side clockwise in the southern hemisphere and right-hand side anti-clockwise in the northern hemisphere. Westerlies. They are prevailing winds from the west moving towards the east in the middle latitudes between 30 and 60 degrees latitudes in both the hemispheres. They originate from the high pressure areas in the horse latitudes and moves towards the poles and steer the extratropical cyclones in this general manner. Compared to the trade winds, the westerlies are variable in force and direction, especially in the northern hemisphere. In the southern hemisphere, the westerlies blow with regularity and great strength throughout the year. Less land mass in the southern hemisphere. Polar westerlies. The polar westerlies blow from the polar high pressure region to the low pressure region. On their journey towards the equator, they are deflected westward to become the northeasterlies in the north hemisphere and southeasterlies in the southern hemisphere. Sea and the land breeze. Land and sea breezes are prevalent on the narrow strips along the coasts or a lake. It is a diurnal cycle in which the differential heating of the land and the water produces low and high pressures. Sea breeze. During daytime, the land heats up faster and becomes warmer than the sea. Therefore, air over the land rises, giving rise to a low pressure area, whereas the sea is relatively cool and the pressure over sea is relatively high. Thus, pressure gradient from the sea to land is created and the wind blows from the sea to the land as the sea breeze. Land breeze. During nighttime, the reversal of conduction takes place. The land loses heat faster and becomes cooler than the sea. The pressure gradient is formed and the land to the sea, and hence land breeze occurs from land to sea. Factors influencing direction and velocity of winds. Pressure gradient force. The rate of change of pressure with respect to distance is the pressure gradient. When the isobars are close to each other, pressure gradient force would be stronger and is weak where the isobars are apart. Frictional force. Frictional force affects the speed of the wind. It is greatest at the surface and over the sea surface the friction is minimal. Coriolis force. The rotation of the earth around its axis affects the direction of the wind. This force is called the Coriolis force. It deflects the wind in the right direction in the northern hemisphere and to the left in the southern hemisphere. The deflection is more when the wind velocity is high. It is maximum at the poles and is absent at the equator. General circulation of the atmosphere. The pattern of the movement of the planetary winds is called the general circulation of the atmosphere. It depends on the following factors: latitudinal variation of atmospheric heating, emergence of pressure belts, migration of belts following the apparent path of the sun, the distribution of continents and oceans, rotation of the earth. The general circulation of the atmosphere also sets in motion the ocean water circulation, which influences the earth's climate. Insolation and heat. Insolation, incoming solar radiation. The sun is the primary source of energy for the earth. The sun radiates its energy in all directions into space in short wavelengths, which is known as solar radiation. Incoming solar radiation or insolation is the total energy received by the earth's surface in the form of short waves. However, dust particles, water vapor, ozone, and other gases present in the atmosphere absorb a small amount of solar radiation. Sunshine, amount of insolation. Duration of sunshine is recorded as a sundial. One on maps, places with an equal amount of sunshine are joined by isohells. As the earth is a geoid resembling a sphere, the sun's rays fall obliquely at the top of the atmosphere and the earth intercepts a very small portion of the sun's energy. The solar radiation received at the top of the atmosphere varies slightly in a year due to the variation in the distance between the earth and the sun. During its revolution around the sun, earth is farthest from the sun on 4th July. This position of the earth is called as aphelion, 4th July. On 3rd January, the Earth is the nearest to the Sun. This position is called perihelion. Therefore, annual insolation received by the Earth on 3rd January is slightly more than the amount received on the 4th January, 4th July. Thus, insolation is more in summers and less in winters. The major factors which influence the amount of insolation received on the surface of the Earth are the following: 1. Rotation of the Earth on its axis. 2. The angle of inclination of the sun's rays. 3. Duration of the day. 4. The transparency of the atmosphere. Rotation of the earth on the axis. The earth rotates on its own axis, which makes an angle of 66.5 with the plane of its orbit around the sun. It has a greater influence on the amount of insolation received at different latitudes. The angle of incidence of the sun's rays. The higher the latitude, the less is the angle they make with the surface of the earth. The area covered by the vertical rays is always lesser than the slant rays. Moreover, the slant rays are required to pass through a greater depth of the atmosphere, resulting in more absorption, scattering, and diffusion. Duration of the day. It varies from place to place and season to season. The longer the day, greater is the amount of insolation received, and shorter the day, less insolation. Transparency of the atmosphere. It depends upon the cloud cover and its thickness, dust particles, water vapor, etc., because they reflect, absorb, or transmit the insolation. Color of the sky. Very small suspended particles in the troposphere scatter the visible spectrum both to space and towards the Earth's surface. This process adds color to the sky. The red color of the rising and the setting sun and the blue color of the sky are the results of the scattering of light with the atmosphere. Spatial distribution of insolation at the Earth. Maximum insolation is received over the subtropical deserts where the cloudiness is the least. The equator receives the comparatively less insolation than the tropics. Generally, at the same latitude, the insolation is more over the continent than over the oceans. In winter, the middle and higher latitudes receive less radiation than in summer. Heating and cooling of the atmosphere. There are different ways of heating and cooling of the atmosphere: conduction, convection, advection, and terrestrial radiation. Conduction is the transfer of heat by contact. The earth, after being heated by insolation, transmits the heat to the atmospheric layers near to the earth in long waveform. The conduction in the atmosphere occurs at the zone of contact between the atmosphere and the earth's surface. The air in contact with the land gets heated slowly, and upper layers in contact with the lower layers also get heated. Conduction is important in heating the lower layers of the atmosphere. Convection. Vertical transfer of heat. The heating of the air leads to its expansion. Its density decreases and it moves upwards. The cyclic movement, that is transfer of heat from the lower layer to the upper layer, leads to the heating up of the atmosphere. It is confined only to the troposphere. Advection. Horizontal transfer of heat. Winds carry the temperature of one place to another. The temperature of a place will rise if it lies in the path of winds coming from the warmer regions. The temperature will fall if the place lies in the path of the winds blowing from the cold regions. In the middle latitudes, most of the diurnal day and night changes in daily weather are caused by advection alone. Lu is the outcome of advection process. Tropical region. Terrestrial radiation. The insolation received by the Earth is in shortwave forms and heats up its surface. The Earth, after being heated, itself becomes a radiating body and it radiates energy to the atmosphere in long wave form. This energy heats up the atmosphere from below. This process is known as terrestrial radiation. Heat budget. The balance between the insolation and the terrestrial radiation is termed as the heat budget or heat balance of the Earth. As the long wave radiation is absorbed by the atmospheric gases, particularly by carbon dioxide and the other greenhouse gases. Thus, the atmosphere is indirectly heated by the Earth's radiation. The atmosphere in turn radiates and transmits heat to space. Finally, the amount of heat received from the sun is returned to space, thereby maintaining a constant temperature at the Earth's surface and in the atmosphere. The Earth as a whole does not accumulate or lose heat. It maintains its temperature. This is the reason why the Earth neither warms up nor cools down, despite the huge transfer of heat that takes place. Albedo. The ability to reflect the sun, light, and radiation is known as an object's albedo. Albedo can be defined as a measure of how much light that hits a surface is reflected back without being absorbed. According to the ecosystem, the decreasing order of the albedo of the different areas on the Earth's surface is following: tundra, taiga, tropical deciduous, tropical evergreen. This is the decreasing order of albedo.